Welcome to A-Level and AP Physics. In today's lesson, we will discuss typical type of questions on electricity from March 2021 paper 1-2. For this question, it is given to us base of the cloud is 500 meters above the ground and this horizontal line is representing the base of the cloud. So simply we can write down here, this is base of the cloud. And this horizontal line is representing ground. So simply we can draw another horizontal line here, and this is representing ground. It is also given to us the potential difference between the base of the cloud and the ground is 200 megavolts. So it simply means if we connect a voltmeter between these two, the reading on this voltmeter is 200 megavolts. So simply we can write down here. Now if you look at this setup, this is like parallel plates, capacitor. So this is like parallel plates, capacitor. So parallel plates. If plates are parallel, the field between the plates, field is uniform field, means uniform electric field. The field between these two plates is uniform. It is also given to us a raindrop with a charge of 4.0 times 10 to negative 12 coulombs is in the region between the cloud and the ground. It simply means that charge is placed somewhere here and we need to find out the force on this charge. Let's assume the force on this charge means the direction of electric force on this charge is upwards, and we can say that force is Fe. And this is what we need to find out. We need to find out the magnitude of this force. Fe, simply we understand Fe is equal to Eq, and E is the electric field, and in uniform electric field E is equal to delta V over T, means the potential difference between 2 points divided by the distance between 2 points. In this case, the potential difference between these 2 points means between these two plates, or we can say between base and ground is given, and that is 200 megavolts. So this is 200 megavolts. So simply we can say this is 200 times 10 to 6 volts divided by the distance between these 2 points. And the distance between these 2 points is given, that is 500 meters. Now simply we need to plug in values and we can find out value of F. And so we can write down here E is equal to delta V over D, and this is multiplied with Q. Delta V we have, this is 200 times 10 to 6. We need to divide by the distance between two plates, mean base and ground, and we need to multiply with the charge on the raindrop. So the charge on the raindrop is 4.0 times 10 to negative 12 coulombs in coulombs. Now if we solve this one, we will get our final answer, that will be equal to 1.6 times 10 to negative 6 newtons. So this is the magnitude of electric force on this raindrop. So that's the answer. For question number 32, equation is given to us and question is asking us what this symbol small n is representing, means what this symbol is representing. And this question is quite straightforward one. Let's try to understand first of all what is n. N simply represent number of charge carriers per unit volume. Number of charge carriers per unit volume. This represent number of charge carriers per unit volume. So simply we can write down this is what n is representing. Number of charge carriers per unit volume are simply you can say number of free electron. Number of free electrons per unit volume. So we can also write down this is number of free electrons because the charge carriers in a metal are free electrons. So we can say number of free electrons per unit volume. Number of free electrons per unit volume. We can also say this one, N is the number density of free electrons. Another way to say this one is number density of free electron. Number density of free electrons. So that's all what we need to understand to answer this question. If we look at option A, the number of charge carriers in the wire, no, this is not right. Number of charge carriers per unit volume. And N is the property of material. Property of material. material. So this is property of material. It depends on material, and N is different for different materials, or you can say different for different metals. The number of charge carrier per unit cross-sectional area, this is also not true. The number of charge carrier per unit length, this is also not true. The number of charge carriers per unit volume, this is true. Number of charge carriers. So our answer for this question is D, and this is the answer. For this question, it is given to us a cell of negligible internal resistance is connected to resistors R1, R2, and R3 as shown in this circuit. We need to find out which equation must be true, must be correct, must be true. If you look at option A, for this one, it is given to us the power dissipated in R1 is equal to power dissipated in R2 plus power dissipated in R3. For this one, simply we can write down, this is telling us the power dissipated in 1 is equal to power dissipated in 2 plus power dissipated in 3. For that purpose, let's assume current coming from this cell, let's say, is I, and current passing through this resistor 1, let's say this is I1, and current passing through these two resistors, let's say this is I2. Now simply we can write down the equation for power dissipated in these resistors. We can also connect voltmeter. Let's say if I connect voltmeter across R1, the reading on this voltmeter will be equal to the potential difference across the terminals of this power supply, or we can say, because it has no internal resistance, so this will be equal to EMF of power supply. We can say that is equal to V. We can also connect voltmeter across these two resistors. If we connect voltmeter across these two resistors like this, the reading on this voltmeter also will be equal to the EMF of power supply. Now simply we can use this one and we can find out, are these two they're equal or not. So for P1, we can say this is V squared divided by R1. And for P2 plus P3, we can write down this will be equal to V squared divided by the total resistance of these two resistors. Simply we can say R2 plus R3. And this is only true if R1 is equal to R2 plus R3. Only true if this condition is met. So only true if R1 is equal to R2 plus R3. But it is not given to us they are equal. So this option is not possible. So we can simply say they may not be equal. May not be equal. So if this is the case, then option A is not true. They may not be equal. So option A is not correct. Let's go to option 2 now. If you look at option 2, means option B, power dissipated in R2 is equal to power dissipated in R3. So we can write down equation again. For this one, simply we can say P2 is equal to P3, and that this is only possible if I square, we can say I square R2, this is I2, this has to be equal to I2 squared times R3, and this is only true if R2 is equal to R3, but it is not given to us they are equal. May not be equal, maybe not equal. Simply we can say maybe not equal. If they are equal, then it is true, but maybe they are not equal, so it cannot be best possible option. If we go to option C now, for option C, it is given to us the power output of cell, we can say EMF of the cell times the total current passing through the battery. This is equal to power dissipated in R1, we can say this is I1 squared times R1, and next one we can write down this is I2 squared times R2 plus I2 squared times R3. And this is always true because this is simply based on conservation of energy. Means all the electrical energy has to be converted into other forms of energy, or simply we can say this is simply based on conservation of energy. If you look at option D, it is given to us power output of cell is equal to power dissipated in R1. And this is not correct because this is against conservation of energy. All the power output of the cell has to be equal to the power dissipated in all the resistors, mean in these three resistors. But this is telling you only in one resistor. So that's reason this is not correct option. For question number 34, it is given to us a fixed resistor and a diode are connected in series to a battery of electromotive force 6.0 volts and negligible internal resistance. It simply means battery has no internal resistance. It is also given to us current in the circuit is 40 milliamps. If you look at this circuit, we can find current in the circuit. As these two components, they are connected in series, it means current passing through this diode and resistor is the same. We need to find out what is the resistance of this fixed resistor. It is also given the IV curve for diode is given. So IV curve for diode is given. If you look at this curve, current in the diode is 40 milliamps. So simply we can draw this horizontal line and then we can find out the potential difference across diode. So potential difference we can simply read from x-axis. Potential difference, if you read, this will be equal to about 1.24 volts. So this is the potential difference across diode, means if you connect voltmeter across this diode, reading on the voltmeter will be 1.24 volts. Now simply we need to understand EMF of the cell. This will be equal to the potential difference across fixed resistor plus the potential difference across diode. I'm using letter capital D for diode here. EMF of the cell is given. This is 6.0. VR we need to find out. And potential difference across diode is given, that is 1.24 volts. So VR from here, simply we can find out this will be 6.0 minus 1.24. If we simply solve this one, our answer will be 4.76 volts. We can simply connect voltmeter across this resistor and the reading on this voltmeter, that will be equal to 4.76 volts. And current passing through this resistor we have, and value of the current is 40 milliamps. So this is 40 milliamps. Now we need to find out resistance. So resistance, simply we can find out this will be equal to potential difference across the resistor divided by current passing through this resistor. Potential difference across this resistor is 4.76 volts and current is 40 milliamps. So 40 milliamps. Our final answer, if we solve this one, will be 120 ohms. So the answer is B for this question. So this is how you need to approach. For question number 35, it is given to us an electrical cable consists of 7 strands of copper wire, each of diameter 0.30 mm, and they are connected in parallel. Resistivity of copper is given, current in the cable is given. We need to find out what is the potential difference between 2 points on the cable, a distance of 1.0 meter apart. If you look at this sketch, I have already drawn this one, and this gives you very clear picture of this question. And in this sketch, you can see this is the outer side of the cable. So I have sketched this one. This is outer side of the cable. And inside this cable, there are 7 strands. As you can see here, these are the 7 strands, are 7 copper wires inside this cable, and these strands, they are connected in parallel. So we can find out current passing through each strand, means passing through one strand. Simply we can write down here, and that current will be equal to 13/7 because they are connected in parallel, so current will be equally divided. Now we need to find the potential difference between 2 points at a distance of 1 meter. We can take these 2 points on any one strand because they are connected in parallel, so the potential difference across them is the same. Now simply we need to use V is equal to IR. In this case, I is given, that is 13/7. So again, let me write down I. R we need to find out. R will be equal to rho L by A. Rho L by A. Now we can plug in values. Current is 13/7. Rho is given, that is 1.72 times 10 to negative 8. And L is given, that is 1 meter. So L is 1 meter, mean the distance between these 2 points. And we need to divide by the cross-sectional area, but diameter is given. We can say this is pi by 4 d squared. So d in this case is given, that is 0.30 millimeters, and the power of d is 2. Now simply we need to solve this one. If we solve this, our final answer will be 0.5 451 volts. So the answer for this question is C. This is how you can answer this problem.